Hello friends, good morning. So I am Brinda. I am going to handle compiler design. Today I have to explain about introduction to compiler design. So in that, why we need compiler and how it is working. So I will explain these two concepts in today's session. So before that, we have to know about what is meant by assembly language and machine language. So in assembly language, so this is the assembly language. Here some functions we used like store, increment, multiply, jump, load, call. So these are all some assembly languages. Here we can perform some operations. The first thing is considered as the destination and second one is source. For example, mul 801 comma 2 comma 803 means we can multiply these. This is like a register, so we can multiply this with this number, and finally we can store that value in 801. So this is the assembly language. Some simple example. So on machine languages, it is in the form of zeros and ones, binary code. So if your code is in machine language, then only the code is executed by the compiler. Uh, so this is assembly and machine level language. So what is the use of the assembler? How we can convert this assembly language to machine level language means for that we need assembler. So with the help of this assembler, we can convert the assembly language to machine level language. So this is as I already told here some comments are there or some functions are there like move. So here we can perform some functions. So for this function we can convert all these assembly languages in the form of zeros and ones, that is machine level language. So here for a normal C program, this is the some simple structure. Here a header file is not there, so leave it. Main function and some body of the execution is here. It is a machine independent programming language. That means it is not executed by the machine. If you want to execute it, for that first we can convert this programming language into machine level language. Here the programming language is considered as a high level language. So the high level language is converted into machine language. For that we need compiler, assembler and interpreter. So these are all some translator. I will explain one by one. So the programming language is converted to machine dependent programming language. It may be a assembler language. So then the assembly language, it is converted to the machine level language as I explained here. So the assembly language is converted to machine level language. Similarly, here we can perform the same thing. So this is assembly language. That assembly language is converted to the machine level language here. So the main thing here it is we can convert the high level language to assembly language with help of the compiler, and from assembly language to machine level language here we can convert with help of the assembler. So these are all some introduction. Translator. First, what is meant by translator? So in general, translator means we can translate from one language to other language. So similarly here, we can translate high level language into equivalent machine language. Finally, here some translation takes place, but in the result, we can get the same output. That is nothing but the equivalent machine language. So it may be a high level language or assembly language. Finally, we can get the equivalent machine language. So in simple, translator is nothing but we can translate a language from one level to another level. So these are the three types of translator: compiler, interpreter and assembler. So these are the three types of translator. So first one is compiler. In that compiler, a compiler is a program, takes a program written in a source language and translate it into equivalent target language. Here the source language is nothing but the high level language. So as I already told, so in this slide, this is nothing but the source language. It is a high level language. Now that is converted into target program. Target program is nothing but the equivalent machine language. So with the help of this compiler, we can convert the high level programming language into equivalent machine code language. Suppose in between some error message occurs, means during compilation we can correct that error, then only we can convert the high level language to source language with help of the compiler. So in simple, compiler is nothing but we can convert your source program from high level language to target program. It is a machine level language. Next one is interpreter. So in interpreter, here it is similar to compiler. In compiler, we can compiles the code entire thing, or otherwise we can scan the entire code with help of the compiler at a single time. But in interpreter, here we can scan the code line by line or translate the code line by line. For example, in C program, first if you are taking int main, means so for this function, first we can convert this into assembly language or machine level language. But in C, with in compiler, the entire source program is read once or scanned once. That program is converted into the machine level language. So here, interpreter, we can translate the code line by line here. Here also in between, if suppose if error message is there, we can rectify the error here. So the main difference between compiler and interpreter is, the first difference is the compiler compiles the entire code at once, but in interpreter we scans the code line by line. This is the first difference. And in second difference, the compiler it takes less amount of time for execution, but in interpreter it takes more amount of time for execution, because in compiler uh, we can scan the entire program, but in interpreter we scan line by line. So that's the reason for execution compiler takes more amount of time and interpreter it takes less amount of time. The next difference is intermediate code is generated in compiler. Suppose there are many types of compiler: one pass compiler, two pass compiler, and multi-pass compiler. If it is a one pass compiler, means we can directly convert the or translate the high level language to machine code. But we go for two pass or multi-pass compiler, means intermediate codes are generated. So for that intermediate code, we need some space to store that intermediate code. But in interpreter, no intermediate object codes are generated, because here we can scan the code line by line. So that time itself we can translate that code into high level language. So here no intermediate object code is generated. So it is memory efficient compared to compiler. The next difference is, in compiler it's a little bit difficult to find out the error, because the same reason, after scanning the whole program, then only we can find out the error. But in interpreter, uh, whenever the error find, we can debug it easily. So here the if we made the error at the first time or in the first line, that time itself we can stop it and debug the error in interpreter. So these are the main difference between compiler and interpreter. So in compiler, it scans the entire program. Interpreter, it scans the code line by line. In compiler, the execution time is faster, and in interpreter, the execution time is slower. And the third difference is intermediate object code is generated in compiler, so Here more memory is needed, but in interpreter no intermediate object code is generated. So here memory efficient. And the fourth difference is error debugging is comparatively harder compared to interpreter, but here debugging is easy. The first time itself we can find out the error, we can debug it. So these are the main difference between compiler and interpreter. Next one is assembler. So in assembler, here the assembler again we can translate, it is a translator. We can translate the assembly level language to machine level language. Here the assembly level language is nothing but move a comma b or jump a comma b, add a comma b, like that. So that is the assembly language. And machine level language, it is in the form of zeros and ones. So these are the basic types of translator: compiler, interpreter, and assembler. Next one is language processor. So whatever we discussed till now, that are all comes under language processor, like compiler, interpreter, assembler. Other than that, linker and loaders, debuggers and profilers are there. So compiler, interpreter, assembler, compiler, here we can translate a high level language to machine level language as a whole in a single time. But in interpreter, here we can convert the high level language to a machine level language line by line. In assembler, we can translate the code from assembly language to machine level language. So what is the use of linker, loader, debugger means? So the linker, it is used to link. So as I already told, in a compiler, there are three types of compilers are there. So one pass, two pass, and multipass. So if you go for two pass and multipass, intermediate codes are generated. So that intermediate codes or object file that are all linked with help of the linker. So linker is used to link all the object file. And the loader, the loader is used to load the executable file or object file into memory for execution. Debugger, that is used to debug the error. Once you detect the error, you can debug it. So this is language processor, the same thing. So source program is nothing but the C program or a high level language program. Again, this is comes under the other name for language processor is cousins of compiler. So this topic is repeated in cousins of compilers too. The source program is converted to modified source program. Here preprocessor is used to modify the source program, and compiler is used to modify the source program to target assembly program, and assembler is used to target assembly program, that is assembly level language program, to relocatable machine code. So if there are more intermediate object files are there, then we can link it by using the linker and load that into memory for execution. Finally, we can get the target machine code in the form of zeros and ones. So this is language processor. So whatever discussed till now, this is the explanation. So preprocessor, here the preprocessor is a source program. So after header file, some lines we are added. So the task of collecting the source program is entrusted to separate program called preprocessor. Main key point of this preprocessor is it may also expand macros into source language statement. So this is the nothing but preprocessor. Macro substitution, or otherwise we can name it as macro substitution. So it is not actually, the preprocessor is not a part of the compiler. The main use of that preprocessor, it modifies the source code by replacing the header file with some suitable content. So the modified source program is then fed into the compiler. So here preprocessor. This is the source program. We can modify that source program. That modified source program is fed into the compiler. That is the next level. So in that compiler, if the target program is the machine language, then it is can be executed directly. So compiler already know we can convert that high level language to machine language. So if the machine language, if our target program is machine language, then it can be executed directly. That is one pass compiler. Otherwise, if the target program, our output is the assembly language means, then the code is given to the assembler. Here, the target code is our assembly language. It is not a machine language. Suppose if here we can receive the machine level language, it is executed, it is directly executed. But here our target code is the assembly program. So that assembly program is converted to relocatable machine code with help of the assembler. So that's the reason here we are assigning this target assembly level language code to the assembler for translation. Now the assembler translate the assembly level language code to the relocatable machine code. So after that relocatable machine code, the linker links the relocatable code with the library files and the relocatable object files. That is, if we have more number of object files, all the object files are linked with help of the linker. The loader then it puts all the files executable file into memory for execution. So that is the explanation here. um, so as I already told, this is a language processor. So the same thing is repeated here in cousins of compiler. So cousins of compiler, source program is there, preprocessor. After the preprocessing, the source code is converted into the modified source code. Now that modified source code is fed into the compiler. The compiler converts that into target assembly code. If it is a machine code, it is the last step. But here the target code is the assembly code. Again, we can fed that assembly language into the assembler. Now the assembler convert that assembly language to relocatable machine code. If we have more number of object file, the linker link all the library files or relocatable files, then that file is loaded into the memory with help of the loader for execution. So this is cousins of compiler. So up to this, the introduction part is over. So next class, I'll share some other topic. Thank you.